4 barrels of polysubutylene. That looks like motor oil, right? Jesus. They're not making cement, they're making explosives. Catch me in a phone.
Overseeing the operation.
They're heading into a trap.
We're seeing literally thousands of police heading into the sewers, Mr. Mayor. We're literally thousands of police.
It's a training exercise, that's all. Now, if you'll excuse me, I've got tickets to watch our boys thrash Rapid City.
Control, pull everyone out. Maine has been pouring concrete laced with explosives.
Where?
Okay, so the unit circle is called the unit circle because it has a radius of 1. That means any point there's a radius of 1. So this is useful because when you drop a perpendicular, the hypotenuse is always going to be 1.
180. 180 going around, that is pi. So we'll figure out more why later. But because 180 is pi, and if you go up 30, 60, 90, and then to 120, 150, and 180, that would be dividing that into sixths. So you're gonna do this, which is 30 degrees, would start out being pi over 6, because it's one of those sixths. The next one, 60, would be 2 pi over 6, or pi over 3. The next part would be the 90 degrees, which is 3 pi over 6, because it's 3 of those together over 6, or pi over 2. Next would be 120 degrees, which is 4 pi over 6. Next, after 3, or 2 pi over 3. Next, we have 150 degrees here, and 150 degrees is 5 pi over 6. Finally, we have 6 pi over 6. 6 pi over 6, obviously, is just pi, because 6 divided by 6 is 1. Alright, so now we're just going to quickly do 45 degrees, 90 degrees, 135 degrees, and 180. Because you're going up in increments of 45 degrees, it's going to be fourths instead of sixths. So one of those, the first one would be pi over 4, because it's one of those over 4, pi over 4. Then we have 2 pi over 4, which is the same as pi over 2. Then 3 pi over 4 can't be canceled at all. 3 pi over 4. 4 pi over 4, again, 4's cancel, it's just pi.
By using fourths and sixths, you can find the rest of the radian measures around the unit circle. 7 pi over 6, 5 pi over 4, 4 pi over 3, 3 pi over 2, 5 pi over 3, 7 pi over 4, and 11 pi over 6. And then finally you get back to 360 or 0, which is 2 pi.
Let the games begin.
Okay, so to find the coordinates of the point at pi over 6, we're going to drop a perpendicular down to create a right triangle. And because it's at 30 degrees, we have a special triangle, which is a 30, 60, 90 triangle, and with the radius 1. Because the hypotenuse is 1, one of the properties of a 30, 60, 90 triangle is that the side opposite the 30 degrees is 1/2 of the hypotenuse. So y equals 1/2. And then to find the x side, or the x coordinate, you have to use the Pythagorean theorem, which is a squared plus b squared equals c squared. And so 1 squared minus 1/2 squared equals x squared. If you fall down, then 1 minus 1/4 equals x squared. And then so 1 minus 1/4 is 3/4. And so you take the square root of that to isolate x. And then these two are equivalent. And the square root of 4 is 2. So the x side is square root 3 over 2. Opposite over hypotenuse is sine, and because the hypotenuse is 1, then it's just whatever opposite is. And so that is also the same for cosine, so adjacent over hypotenuse. So the coordinates of pi over 6 are root 3 over 2 and 1/2.
So now we're going to do the 45 degrees, which is pi over 4. Now we know that this is 45 degrees, and because we dropped a perpendicular down from the line, we have a 90 degrees. That leaves 45 degrees here. Now this means that this triangle is isosceles. What we know about isosceles is that well, normally with the Pythagorean theorem, a squared plus b squared equals c squared, the length of the hypotenuse. But what we do have to do is know that the two lengths on the side, or x and y as we called them before, are now equal. So what we can do with Pythagorean is that a squared plus a squared equals 1 squared, because we know that the radius is 1 in this case. Adding these together, it's 2a squared equals 1 squared. Divide both sides by 2, a squared equals 1/2. Take the square root on both sides, and what you find is that this is equivalent to this, and then this is also equivalent because here we have root of a squared, it's just a, and then here we have that the square root of this whole thing is the same as the individuals. What we do have is that it is rude to leave a square root in the negative. Thank you, Ms. Friel. So we have to do root 2 over root 2, which is 1. And this, in fact, will cancel out with the root 2 times root 2, giving just 2, because the square roots times each other. And then this, which is just 1 times root 2. A equals root 2 over 2. A is the same for both of these sides because it is isosceles. So what we know is that our cosine, which is our adjacent over our hypotenuse, is root 2 over 2. And then our sine, which is our opposite over our hypotenuse, is also root 2 over 2.
Okay, 60 degrees, or pi over 3, you use the same strategy as 30, 60, 90, except this time 60 degrees is right here. We know that side opposite 30 degrees is 1/2, so x is 1/2. Y is the side opposite 60 degrees. You use the same math as before with Pythagorean theorem, except this is, we're solving for y instead of x. You run through the equation, you get root 3 over 2, like you did before, and so this time y is root 3 over 2, and so the cosine, which is x, is adjacent over hypotenuse, so 1/2 over 1 is just 1/2, and so the y coordinate is opposite over hypotenuse, which is root 3 over 2.
Okay, for all the quadrantals, that is at 0 degrees, 90 degrees, 180 degrees, and 270 degrees. There is no perpendicular line that you can drop. There is no way that you can solve for the points in that way that we've been doing. What you can do is think of it like a grid, or as a point system, like where you plot points. So it's you have this which would be 1, 0, because there's no height this way. So it's 1 on the x. Again, radius is 1. Then we have this, which is 0, 1, because you have 1 in height but 0 along the x-axis. Then you have -1 in the x and no height, so it's 0 in the y, and then -1 in the y and 0 in the x again. So that's how you solve for those quadrantals.
You can find all the points by using the same method of dropping the perpendicular and solving for the sides in the rest of the unit circle. However, in this quadrant right here, the x is negative and the y is positive because it goes to the left and it goes up. In this, it goes down and to the left, so both x and y are negative. And in this quadrant, x is positive, however y is negative.